So now moving on to the green medium. Is referred to as PTCs. So not only are we going to talk about its ability to be a green solvent, but also its ability to be a green catalyst. And that is why the flexibility of PEG is so important. So starting with PEG's ability as a solvent, the experiment we're going to be looking at is by Borges and his colleagues when testing solvents for the synthesis of vinyl sulfide from alkynes and thiols. They reported that low yields were found when using glycerol, ethanol, THF, and even no solvent. However, when they used PEG 400 as a solvent and at temperatures of around 60 to 80 degrees Celsius, the yield increased dramatically to 84 to 87%. Now, PEG 400 was used as a green and recyclable solvent in an efficient and straightforward method for the synthesis of unsaturated esters, ketones, and aldehydes through the hydrothiolization of alkynes under base and catalyst-free conditions. These reactions were then performed under mild conditions, which supplied the respective unsaturated compounds from alkenyl esters and ketones in good yields with moderate reaction times. So then moving on to PEG's ability to function as a green catalyst, Panduri and his team developed an improved method of synthesis of pyrrole using water as a solvent and PEG 400 as the catalyst under metal-free conditions. This reaction was a one-pot reaction of isoxazolyl, N-amino esters, and nitroolefins using water as the reaction medium and PEG 400 as the catalyst. And in that reaction, figure 2, PEG acts as a lewd acid to create the final product. So now we're going to move on to the discussion section and discuss why PEG is so important as a solvent and as a catalyst in these respective reactions. So starting first with PEG as a solvent, Borges and his colleagues discovered that the use of PEG as a solvent can be used in base and catalyst-free conditions in the synthesis of vinyl sulfides from alkynes and thiols. Now, why is this so important? Because under base and catalyst-free conditions, it's significantly less toxic to the environment. The reaction also had high atom economy, and PEG 400 was reused up to 5 times, obtaining good yields every time without previous treatment. This means PEG was used as a recyclable solvent for clean organic synthesis. Now moving to PEG as a green catalyst, the Panduri team experiment showcased PEG's ability to work as a catalyst under metal-free conditions with water as the solvent. Because it is metal-free, the reaction was environmentally benign, which is important to green chemistry. According to Panduri and the team, the reaction time was less than other solvents that were tested and also had great yields. PEG could be reused and recovered several times, and most importantly, the reaction process was green. So that's exactly why PEG is so important in flexibility to be both a green solvent and a green catalyst.